Let's talk about circles and the various lines and segments that can be drawn inside of them. A circle is a set of points that are all the same distance from a given point. That point in the center of the circle is creatively called the center of the circle, and all of the points on the circle are the same distance away from the center. Technically speaking, the circle is just this black ring. The yellow part in the center isn't technically the circle, it's the area of the circle, but the circle is just the set of points that are the same distance away from the center, so the black circle is really the only thing that counts as the circle. Circles are named using a circle symbol, and then the name of the center. So this circle would be called Circle P. Now that we know what a circle is, let's talk about all of the lines and segments that can be drawn inside of it. For example, a radius. A radius is a segment that connects a point on the circle to the center of the circle. For example, PQ. P is the center, Q is a point on the circle, so PQ, that segment, would be called a radius. All of the radii of a circle are the same length, so every single radius that you draw, all of these little red segments, they're all the exact same length, and they all count as a radius because they connect the center of the circle to a point on the circle. Now looking at this diagram, you'll notice some of our radii go all the way across the circle. They go from one point on the circle through the center to another point on the circle, like ZX or QT. These are called diameters. So AB in this diagram would be considered a diameter because it connects a point on the circle to another point on the circle, but as it does so, it passes through the center. If it doesn't pass through the center, then it's called a chord, like GH. G is a point on the circle, and so is H, so this segment connects 2 points on the circle, but unlike AB, it didn't pass through the center as it did so. So GH would just be a chord, whereas AB is a diameter. Secants are really similar to chords, except they're lines instead of segments. GH was a chord because it was a segment. It ended at the points on the circle. Whereas XY is a secant, it connects 2 points on the circle, but then it also extends infinitely outside of the circle, as indicated by the arrows. And the final segment that we'll talk about today is a tangent. A tangent is a line that intersects a circle at exactly one point. So you'll notice the other point that we put onto this line is not on the circle, it's outside of the circle. And that's because this tangent only hits the circle at one point, point M. We're going to learn a little bit more about tangents later on in this video, but first let's practice what we've learned so far. I want us to draw each of these figures inside of this circle, starting with radius AX. Well, that means I need to connect point A, which is a point on the circle, to the center, point X. So this would be a radius. Then let's draw a diameter FC. If I connect point F to C, you'll notice that it passes through point X as it does so. That makes it a diameter because it connects 2 points on the circle and passes through the center as it goes. Whereas chord BD, if I connect B to D, it did not pass through point X, which makes it just a chord, not a diameter. Secant EC, I'll connect these 2 points, but I also have to draw arrows outside of the circle. The difference between a chord and a secant is that chords are segments. They end at the circle, whereas secants are lines. They extend infinitely outside of the circle. Then I need to draw tangent AG, but I don't see G anywhere on my diagram. And that's because it's a point that I need to draw somewhere outside of my circle, because a tangent only intersects a circle at one point, in this case point A. So I'll draw G out here somewhere and draw a line that goes only through point A. But why does this happen this way? How do I know where to draw point G? Well, let's talk a little bit more about tangents. The only way for a line to be a tangent of a circle is for the radius that hits that point to be perpendicular to the tangent line. So in this diagram, we see that line TN and segment GA are perpendicular to each other. That guarantees that the only point where line TN hits this circle is at point A. That point where it hits is called the point of tangency. So A is the point of tangency. It's the only point where line TN intersects circle G. If you're talking about more than one circle at a time, we have both common internal and common external tangents. It's possible for a line to be tangent to more than one circle. And if that tangent line intersects the segment that connects the centers of those two circles, then it's considered a common internal tangent. Basically, the tangent passes in between the two circles, as opposed to a common external tangent like EF. This line is perpendicular to radius AE and radius DF. That makes it tangent to both circles, but it does not intersect the segment that connects the two centers, and therefore is considered an external tangent. So let's review what we've learned so far. If I connect point P to point Q, well, that segment doesn't actually get a special name, it's just the segment that connects the centers of the circles. But if I connect P to R, well, that's a radius, because it connects a point on the circle to the center of the circle. What about VU? VU connects 2 points on the circle, and it passes through the center as it does so. That makes VU a diameter. RU would be a common external tangent. This tangent line does not intersect the segment that connects the centers, and therefore it would be considered external. WS is another diameter. It connects 2 points on the circle and passes through the center as it does so. TQ is another radius. It connects a point on the circle to the center of the circle. ST is another tangent line, but this time it does intersect the segment that connects the centers. So the ST would be considered a common internal tangent. And last but not least, we have WX. WX would be a secant. It connects 2 points on the circle, and it extends infinitely outside of the circle. Therefore, we would call it a secant. In our next example, everything's already drawn for us. We just have to identify what it is. Like point D. Point D is the center of the circle. And point E is a point of tangency, because that's the point where tangent EF intersects radius EH. So we would call that a point of tangency. Segment AF is a diameter because it connects 2 points on the circle and passes through the center. CB is a line. You can tell that it's a line because of the symbol that's on top of the letters. So it connects 2 points on the circle and extends infinitely outside of the circle. We would call that a secant. EH connects a point on the circle to the center of the circle. We call that a radius. EF is a common internal tangent. Even though we don't have this segment drawn that connects the two centers of the circle, we could envision that it was there and see that line EF intersects that segment, therefore it would be considered a common internal tangent. EI is a segment that connects 2 points on the circle, but it does not pass through the center, so we would call that a chord. And IG is tangent to both of these circles, but it does not intersect the segment that connects the centers, so we would call that a common external tangent. And that's all you need to know about the parts of circles. In our next video, we're going to be discussing what an arc is and how to measure it.